So now BMD. So yeah, because there is Scherf's diagram goes through the zero, so we should be careful with this point. Looks like in the middle, like 1 meter, but we will calculate that. But okay, we can 5/5. Yeah, it's 1 meter because this is 5, this 5, and there are 2 meters, so it's symmetrical. Okay, so how we start? So what we know about the bending moment diagram, that at the hinges it's 0, but this hinge, so hinges are very important for bending moment diagram. Here it could be, it could not, it does not affect influence the diagrams for the forces, yeah, kilonewtons, but moment, that's different. And so this is 0 for this hinge, that's so 2 zeros, but this 0 is only from the below, yeah, not, this is straight member, like 8 meters long beam. Where else? Yeah, 0 is at the end of the frame, point C. Here no, this is the fixed support, and A is 0 at the point, because that's a roller. For roller and pin supports, there should be zeros. There are zeros at the end. So which points we need to calculate? This one not so. This from left, from point E from left and point E from right. B, this one, because there should be extreme, and yeah, and don't know where to start. Yeah, well, let's start from the ends going to the middle. So for example, this MB is should be 4, no, 6, because bending moment support direction is 6. And which side, where the tail is. That's why this first one was incorrect. The direction, so where the tail is. If there's a tail for bending moment left side, so we draw 6 here. That's 6. This point we calculate. Let's calculate. Don't know, MP. Yeah, MP. Looking down only. So MB, that's 6. This 6 MB, and we will subtract HB times 3. So -6 and -4 times 3, 12. It's -18. We already saw this value somewhere, isn't it? So that's 6, it will go more, yeah. -6 minus 12, -18. Yeah, good to know that the minuses are left side, where the tens, there's 10 side in tension, and that's the side where we draw the bending moment diagram. And this we go 0. Yeah, there's no forces between P and point E, so it goes 0. Similar we do with this, but there is no fixed support, so it will be just triangle. Yeah, there is almost triangle and kind of trapezium. So AJ, we look at the AJ only, and then look which side is the tail. You know? Tail is the right side, so we draw the triangle right side. 6 times 3, again 18. Many 18s, okay. 18, and that's it. That's a triangle of standard cases, actually. So that's it for these 2 columns or walls. what was the hardest part? This I bet, or to know the rules. Yeah. So we draw the triangle right side, and then we just connect to the 0. And I would for this horizontal, I would start from also again from the free end, so point C, and no, I want to say we see there is a tail side downwards, but no, there is also distributed load. So we should just calculate M max. That there will be this extreme. So we see, but because we are looking right, there is a difference in signs. There will be like right opposite the sign. That's why I put negative in front. Then I follow normal direction kind of. Yeah, you can choose your way. So it goes, it turns, rotates negative around this point. VC times 1 meter. This max is 1 meter, and distributed load Q times 1 times half of 1. That's it. So negative, we see 5 times 1, 5, and plus, so minus 5, plus 5, 2.5. So it's negative, and at the end it's positive. Yeah, 2.5 should be like going. This is positive, downwards it is positive, so it will go or up. Similar, it will be M 2 meters, where the P is 2 meters from right side. Again, this sign, be careful. The same, VC times 2 plus Q times 2 times 1. Negative minus 10 plus 10. See, 0. Interesting. And I will copy, because the same we will do for 4 meters from the point E to right. So 4 meters, 4 and 4. See, so easy. Okay, but be careful. Yes, look at this. 5 times 4, 20, minus 20. And 5 times 4, 40. 20, but minus should be minus 20. Okay, so what we found, that this is minus 20. That's 0, and that's 2.5. So there is parable. Bit look like this. So this is 2.5. This is 0. The verification would be calculating E to the left side, but these two will cancel each other the road, so it will be 5 times 4 times 2, and it is really 20. But there's parable still. Like, nice one. That's it. Wasn't hard, yeah, not so good example for like calculating, like for studying, but anyways, yeah, for getting the result you need to know just some rules, like triangle where the tail is for the end and the arrow. It did not happen here because so much, because there are 2 loads, then there should be calculation. And there's also tail side. In tail side means side intention. That's important for civil engineers. See, that's the result. So for your homework, non-mandatory, let's just change some numbers. Let's I made that this is like easy, but let's make that these are 2 meters and these are 3. See, it will not be 0 then. 3. There's no kind of okay, there's no importance to divide that, so 5 meters, and that's it. This one will not be 5 meters anyway anymore. 8 kilonewton, not meters, newtons. Let's double 20. Yeah, see. So there's also 20. And this is the 7, 6, 9, and the height 4 meters and 4 meters, that be more bigger numbers. Yeah, in the middle. That's your homework to practice. The answer should be very similar. Okay. Thanks for watching.